All right, guys, this is 2013, number 5. I got a question about this as well, so let's go over it. Consider the differential equation dy over dx equals y squared times the quantity 2x plus 2. Let f of x be a particular solution to the differential equation, and this is the initial condition, f of 0 equals negative 1. So A, you're going to find the limit as x approaches 0 of f of x plus 1 over sine of x. All right, so here's the deal. Plug in 0. We don't know f of x, correct? But we know the initial condition right there. We know that when we plug in 0 into f of x, we're going to get negative 1. So the top would be, sorry, I didn't want to do that. The top would be negative 1 plus 1 over sine of 0. We should all know sine of 0 is 0. This leads to 0 over 0, which we all know is an indeterminate, which leads to more work. So then we have to say by L'Hopital. So by L'Hopital, we then are going to take the limit as x approaches 0 and take the derivative. Well, what is the derivative of f of x? The derivative of f of x is, f prime of x, or dy over dx, which is our problem right there. The problem that they gave us right here. So that's going to be y squared over 2x plus 2 plus 1 over here. Well, the derivative of 1 goes away, over the derivative of sine of x is cosine of x. Now, plug in 0. Now, I already know I'm not going to do L'Hopital again because cosine of 0 is 1. So I'm not going to get an indeterminate. So I just have to do the top part. Let's see. Plug in 0 into 2x plus 2. 2 times 0 is 0. 0 plus 2 is 2. But what's y? Well, remember, when x is 0, y is negative 1. That's the initial condition. So that's going to be negative 1 times 2 divided by 1. It's going to be negative 2. And there you go. That is the answer for part A. This is a 2-point problem here. You get 1 point by identifying the fact that you used L'Hopital. Got it? So make sure you do that. All right, part B. I'm going to do the next page. Answer from part B here. This is actually a positive one. So this becomes positive 2. Because it's negative 1 squared. So this becomes positive 2. Part B. Use Euler's method starting at f of x equals 0 with 2 steps of equal size to approximate f of 1/2. Euler's method. Let's remember Euler's method was saying, all right, if I take to get that next term, let's see, f of x of, I can't remember the exact terminology of it, like n plus 1. It's approximately f of x sub n plus the derivative of f of x sub n times delta x. And remember, we said this is literally, really, hey, y is approximately y1 plus derivative is slope times x minus x1. This is just another way of doing all this. Got it? Except you're going to use the derivative up there. And you're going to do the f of 0. Oops, f of 0. This is being annoying. There you go. Equals negative 1. The delta x should be the same. Now you have to think about this, guys. If I'm starting at 0 and I'm going to a half and I'm doing this twice, that means I've got to be going by, delta x has to be going by 0.25, or you can use 1/4. Got it? So that means that we're doing Euler's method twice. So starting at 0 plus a fourth, so that means the first time it's going to be, okay, f of a fourth, is approximately my y1. Well, that y1 I already know is negative 1 plus m. So I got to plug that into my derivative up here. So negative 1 squared is 1. Oh, that is negative 1 squared, by the way. That changed. Okay. So negative 1 squared is 1. 2 times 0 is 0. Plus 2 is 2 times 1 is 2. X minus x1, or my delta x, is 0.25 or a fourth. Got it? Now, it is up to you depending on which one you are better at. Are you better at decimals or are you better at fractions? Go from there and figure out what you're better at, and that should help you out. I can do both. So this would be 1/4 times 2 should be a half. So this is really negative 1 plus a half. And then negative 1 plus a half is negative a half. If you wanted to use the decimals, you could have said, okay, negative 1 plus 2 times 0.25. This should have just gotten you, okay, 2 times 0.25 would have been 0.5 plus negative 1, which is negative 0.5. Same thing. So that's Euler's method once. So now let's do it again. So after a fourth, I now have at a half. Now, my y1, I'm not going back to negative 1. I'm going to the y1 I just solved for right there. So that's going to be negative a half. Plus my m, I got to put in a fourth and a half into my derivative up there. So 1/2 squared, or negative a half squared, that's going to be negative a fourth, times 2 times a fourth is a half, and then a half plus 2, let's see, so that would be a half plus 2. Sorry, 2 times a fourth is 1. So I'm being dumb. No, that's a half. Yeah, that's still a half. Plus 2, and then times my x, my delta x, which is also a fourth. All right, so let's simplify all this craziness. So this is still negative a half. Let's see, a half plus 2, 2 times 2 is 4. That's going to be, so this part here should be 5 halves. But all these multiplied together, so negative 1 plus 5 times 5 times 1 is going to be negative 5 over 4 times 4 times 2. That's going to be 16 times 2 is 32. Which, then, if I need a common denominator, that would be 16, negative 16 minus. I get negative, let's see. I keep forgetting that this is really squared, so this should be a positive a fourth. So this is really positive 5 3/2. That makes it more sense. Okay, now this is 11 30-seconds. There you go. Again, you could have done this with decimals and gone from there. The decimal version would have been 0, probably been a little harder, 0.343. All right. Part C. Find y equals f of x, the particular solution to the differential equation with the initial condition f of 0 equals negative 1. So this is just like the last problem that I did as a video, where you need to solve the initial condition. That means I want the y equals. I want the y by itself. First step, separate the variables. So the y's all go on the left, the x's go on the right. Well, to get y on the left here, I got to divide by y squared. So that becomes dy over y squared equaling 2x plus 2 dx. Then, after we separate the variables, which is just a point, you get a point just for doing that right, take the antiderivative. Now, the right side is pretty easy. This should be just x squared plus 2x. And don't forget your plus c. You get a point just for writing that plus c. The left side, this is not natural log. Why is it not natural log? It's because that y is squared down there. Remember, it's only natural log if it's to the first power in the denominator. Here, we're going to do a don't fight it, rewrite it. This is really y to the negative 2. And now I just have to do my power rule. Negative 2 plus 1 is negative 1 divided by negative 1. This is really negative 1 over y. Now remember, whole goal is to get y by itself and to solve for the c. Got it? So at any point you could do that. If you want to solve for the c now, let's solve for the c now. How am I going to solve for c? I'm plugging in that initial condition f of 0 equals negative 1. Okay, so this is negative 1 over negative 1, that's positive 1, equals, that's 0, that's 0. That means that's my c. c just equals 1. So that leaves me with negative 1 over y equaling x squared plus 2x plus 1. Well, now I gotta get y by itself. Multiple things that we can do here. First off, where is the y? It's on the bottom. You want to take the reciprocal? That's cool. That becomes negative y equals 1 over all of that, x squared plus 2x plus 1. Still don't have y by itself. That y is negative. So if you want to make it positive, just move that negative over. So that's going to be y equals negative 1 over x squared plus 2x plus 1. And there you go. Hopefully I will talk to you guys and see you on Friday. And I'll give you all the info about the AP test then. Bye.